Hello, hello, hello. Welcome back to Shiksha DaCosta. Today we're going to be talking about translating quadratic relations. And this is part of our unit on connecting graphs and equations of quadratic relations. Today we're going to learn how the variable a will affect the graph of a quadratic relation, y equals a x squared. And you're successful at these skills when you can determine, through an investigation using technology, the roles of the variables h and k in quadratic relations that look like this. You're going to be able to describe these roles in terms of transforming the graph of y equals x squared. That's how you know that you've succeeded today. To start us off today, I'll invite you to think about what is happening in this clip, to the shape in this clip. Can you describe this transformation, how the shape is being transformed, just using some basic words? Well, one of the ways that I would describe it is that seems like it's being shifted. It's being shifted up, down, up, shifted to the left, to the right. Another way to describe that would be translating something, to move something in such a way that it does not get distorted or rotated is called translating. Today we're going to do a quick investigation on translations of quadratic relations. So on Desmos, if you were to graph these three relations, and they're all quadratics, they all have a square here. These are quadratics of the form x minus h all squared. What is happening to the graph of y equals x squared as the value h is changing from 0, so x minus 0 would just be x. What if we changed it to 2? So this would be x minus 2. Where would the new quadratic relation, where would the new parabola end up being? Well, we can see that as we change it to 2, the parabola, seems like it has been moved over towards the right. And if I look at the vertex, I can see that the new vertex is 2 units to the right. And in fact, if I look at any other point here, like this one, I could see that 2 units to the right, that's where that point normally would be. So I seem to have a pretty good idea of where the main points are and how they've been moved. All been moved 2 units to the right. Will that hold true over here as well? If I were to graph x minus 5 all squared, so in this case the value of h is positive 5, now it looks like the quadratic has moved even further to the right. And if I count the point from the vertices, the distance between these vertices, it looks like the vertex has been moved 5 units to the right. So in conclusion, I can safely say that as the value of h increases, the parabola is being translated to the right by h units. So when h was 2, it was 2 units to the right. When h was 5, it was 5 units to the right. Let's look at what happens when we decrease h. So in this case, I'm going to start making h negative. Okay, and the thing about that is this will become x minus, I'm going to change it to negative 4. So I'm going to make this x minus negative 4, which would actually simplify to x plus 4. So here you can see I've got x minus h, and h is negative 4. And when I'm subtracting a negative, that's the same thing as adding a positive. So in this case, when h is a negative number, it looks like the parabola has been translated to the left by, let's count here, 1, 2, 3, 4 units. Weird, that's the same thing as the value of h. 4 units, but because it's negative, it's not moved to the right, it's moved to the left. Will that still stay true here? So here I see a parabola. It has been shifted, it looks like, to the left by a very small amount, not even 1 full unit. It looks like only 0.75. It has been shifted to the left by 0.75 units. So it looks like this is still true, right? The parabola is being translated left by negative h units. In the second section of our investigation today, let's look at what would happen if we change the value k here in this equation right here, x squared plus k. So if k is 0, then this is just y equals x squared. And this is the parabola that we all know. Now I've made the y scale a little bit more compact here. I've gone up by tens just to show you sort of what is going to happen because I want you to see all of these points. If I make the value of k 2, so this would be x squared plus 2, you see that all of these points have been moved, translated up, and it looks like they've been translated up by 2 units. This is 2, 4, 6, 8, 10. So each one of these sub-grid lines are just 2 units. These minor grid lines are 2 units apart. What about if I make the value of k 5? In this case, it looks like all of the points have been moved up by 5 units. So I can pretty safely say that this parabola is being translated up by k units. What about if k is negative? So if this is, again, k at 0, so it's just y equals x squared, what if I made k a negative number? In this case, it's negative 4. Taking a look here, we see all of the points still exist. They haven't moved left or right. They're still in the same vertical line. But it looks like they have been moved down by 4 units, just like I thought. And in fact, when this value of k is not even a whole number, negative 3 over 4, negative 0.75 in other words, all of the points have been moved down by 0.75 units. So it looks like the parabola, when k is a negative number, the parabola is being translated down by negative k units. So in this case, it was moved down by 4 units. In this case, it was translated down by 3 over 4 units, or 0.75 units. So just to summarize that, the graph of y equals x minus h all squared plus k is congruent, which means it looks exactly the same as the graph of y equals x squared. The only difference is it is translated horizontally, so left or right, and vertically up or down. When h is greater than 0, when h was a positive number, the parabola, which seems to have been translated to the right. And when h was a negative number, when it was less than 0, the parabola was translated to the left. When k was greater than 0, when k was a positive number, the parabola is translated up. And when k was negative, the parabola translated down. So these are the 4 different ways to translate a parabola: up, down, left, and right. And they all depend on the values h and k. Let's look at that in action. Let's look at 2 examples here. In the first example, I'm going to find the vertex of this quadratic, y equals x plus 2 all squared minus 4. This is the quadratic y equals x squared. And in this example, the value h is negative 2, and the value k is negative 4. How did I get negative 2? Doesn't it say x plus 2? Yes, but remember this is x minus h. And the way we would have reached plus 2 is we would have done x minus a negative 2, and that would have simplified to positive. So this is a little bit tricky. This is the thing that confuses students very often. The value of h is always the opposite of whatever it is you see over here in the quadratic equation. So in this case, the value of h is negative 2. And when h is a negative number, remember that means that negative 2 means it was translated to the left by 2 units. And because the value k was a negative number as well, it means it was translated down by 4 units. Okay, so this is the situation we find ourselves in. Let's start to actually move this parabola. So left 2 units, and now down by 4 units. This is the new location of our parabola. And the vertex is very clearly at -2 and -4. That is the coordinates of the vertex. Now, if the vertex starts at 0, 0, and it moves left or right by h units, and it moves up or down by k units, that sort of means that the vertex will always be at these coordinates, right? It will always be at whatever the value of h is and whatever the value of k is. In this case, -2 and -4 were exactly the values of h and k. So this example kind of confirms our suspicions to be true, that the vertex is always at h, k. Let's try to sketch a parabola just from the equation. So this is the parabola y equals x plus 2 all squared minus 4. We did kind of sketch it out in our previous example, but let's do it one more time. And this time I'm going to do it by transforming the points of the quadratic y equals x squared. Where is their new location going to be? Well, in our investigation, we saw that in this example, the value of h is -2. Remember, it's always the opposite of whatever you see here. And the value of k is -4. So the x values of this basic quadratic have all decreased by 2. And the y values have all decreased by 4. In other words, I could just take all of these x values and I can subtract 2 to find the new x value. That's -5. -2 minus 2 is -4. And I can do that for all of these x values right here. I can find out what are the new x coordinates, because all of them have gone down by 2. That's what happens when you move something 2 units to the left. For the y coordinates, all of those have decreased by 4, so I can take all of these and I can subtract 4 from them. 9 minus 4 is 5. 4 minus 4, 0. 1 minus 4, -3, and so on and so forth for every single y coordinate. And so my quadratic, this is the original quadratic, y equals x squared. Where has it moved to now? It has moved to the left 2 units and down by 4 units. And so here is where we find it. And did our work here confirm our guess? Let's see, -5 and 5, -5, 5. Yep, there is that point that used to be at -2, -3 and 9. -3 and 9, that's where it used to be. Now it's at -5 and 5. The next point used to be at -2 and 4, which is right here. And now it's at -4 and 0, which, yes, we figured that out. So instead of transforming it sort of by shifting things over, I can just use a table of values to find out the coordinates of the quadratic after it has been moved around. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.